Okay, we're going to start with a quick warm-up here. And I have a question for you guys, and it's how do you locate points on the Cartesian plane? Anybody have an answer for that? Really? You don't know how to? So if I give you a point like in the top left of the Cartesian plane, you don't know how to locate it? Think about that. Okay. Well, we use something called coordinates. Okay. By the way, look, it's almost winter break. Think about how fast August went. Look at the Cartesian plane. Well, we've got the quadrants there, quadrants 1, 2, 3, and 4. And we've got the origin. And then we've got that P with 3, 5. What are 3 and 5 called? You can either speak it out or type it into the chat box. What are 3 and 5 called? X and Y coordinates. Very good. So coordinates are the way that we locate points on the Cartesian plane. Does everyone understand how to plot coordinates? Give me a thumbs up if you know how to plot coordinates. Thumbs down if you don't. Let me ask you a quick question. The point 6, 0, what quadrant is 6, 0 in? What quadrant is 6, 0 in? A lot of people are saying 1. It's actually on the x-axis. The x and y-axis are not in any quadrants. Okay? So if you lie on an axis, you're not in any quadrant. It's actually between the first and fourth quadrants. Okay. Distance formula. We've done the distance formula before. It comes from the Pythagorean theorem. Okay? So I'm going to exit out of this for a second, and we're going to do a quadratic formula type problem. Okay? Dot. Okay. Does everybody see my paper right now? Okay. So let's do something simple, and let's say I want to find the distance from 0, 5 to to 10, comma, -3. Okay, if I want to find the distance, I draw a line right there, and I want to imagine the right triangle that it forms along the grid lines. If I can find y and x, and when I say y and x, I mean the blue portions of this triangle, I can use Pythagorean theorem to find the hypotenuse, which is going to be my distance formula. So let's find y. Well, y is the distance from the y coordinates. So I just look at the 5 and the -3, and I use my regular linear distance formula, which is absolute value of the difference. That gives me 8. That makes sense. I went from the 5th floor down to the -3rd floor. I changed 8. How about x? X is going to be the how far I ran. So I ran from 0 over to 10. It doesn't matter what order you subtract them in. We're still going to get a positive 10. And I'm going to call this hypotenuse d for distance. Well, the distance squared equals x squared plus y squared, as we learned from the Pythagorean theorem. Distance squared equals 8 squared plus 10 squared. Distance squared equals 64 plus 100. Distance squared equals 164. To do our final step, we have to take the square root. Now, I know I told you that when you take the square root, you take plus or minus. But for this is distance formula. There is no negative distance. So we're going to do the positive square root. And we can either use a decimal or we can simplify it. Do you know how to simplify square roots like this? Let me go through my way because I don't know the biggest perfect square that goes into it. So I'm going to do factor tree. 2 times 82, 2 times 41. That's already prime. I can change this to radical 4, radical 41, which is 2 radical 41. I hope I'm right. We can write the entire distance formula using Pythagorean theorem. If we use what we did above, we would notice that the distance squared is equal to the difference of the x coordinates squared plus the difference of the y coordinates squared. These are what were in our absolute values earlier. Notice that when you square them, they become positive anyways. We don't need the absolute values anymore. And now I can write the square root, and I can simplify these. x1 minus x2 can be written as delta x. That means the change in x or the difference of x. Delta means difference. And right here, delta y squared. And when you're doing delta x and delta y, it doesn't matter what order you go in, because when you square it, you're going to get the positive answer anyways. What do you think? I see 1 thumb up. 2, 3. Oh, thumbs are going up. So you guys were taught well last year. That's good. Very good. Okay. So just for the heck of it, let's do a crazy question. Ready for this one? Okay. Find all points whose distance from 3, -1 is 10. Okay, so it's a distance formula. Let's see here. And maybe you should watch me do this rather than trying to copy it down, because you have the video. You can rewatch the video later. I think you'll get more of it if you watch me for a moment and jot some little notes. So let's let x, y be a point whose distance is 10. I can apply the distance formula, and I'm going to use my first one, which said 10 squared equals, now I'm finding the distance between these 2 points. So I need delta x squared and delta y squared. 100 equals x minus 3 squared, y plus 1 squared. Does anyone recognize what type of equation that is? Okay. Later on, when you get a chance, and for those who are watching right now on video, I want you to pause the video and go to Desmos and do it. So once you've graphed it, you're going to find out that it's actually a circle. 3, -1, and your radius will be 10. That is all the points that are 10 away from 3, -1. And that's the way the equation of a circle looks. We'll go over that in more detail in the future, the next couple days. I just wanted to introduce that because it's directly related to the distance formula. Okay. Proceed. Okay. We're going to go back to our Google Slides right now. And let me present a tab. Chrome tab. And here we are. Okay. How would you verify a triangle is a right triangle? Well, you can use the distance formula on the three different sides and show that it fits in the Pythagorean theorem. Be sure your longest distance is your hypotenuse when you test it. The midpoint formula. Let's read this. The midpoint formula is just the average. You find the average of your x coordinates, you find the average of your y coordinates. Okay, let's come back to the paper. Now let's see how that works. So first I'm going to do a number line. Let's do really simple. 100 and 150. What's the midpoint of those 2 points on the number line? You can type it in the chat. I like to see who gets it. All right. 125. Do you know how I found it? I took the average. 100 plus 150 divided by 2 gives me 250 over 2, which is 125. We're going to do the same thing with x and y coordinates. For example, if I have -1, 5, and I have 9, 0, and I want to find the midpoint of this segment, all I have to do is find the average of the x's, the average of the y's. My x coordinate will be -1 plus 9 divided by 2. That's 4. My y coordinate will be 5 plus 0 over 2. That's 2.5. My midpoint will be 4, 2.5. We'll call it M. And it's about right there. You'll do much better if you have graph paper. Does that make sense? Do you understand? Okay. Obviously, the problems won't really be that simple. There'll be a different variety like this. Try this example. M is the midpoint of segment AB. And you know when you're doing segment, you must write the line on top. Okay? If you write AB by itself, that means distance. AB with the line on top means segment. So, if A is at 6, 2, and M is 4, 7, find B. Now, I would go ahead and graph it until you become really good at these. So 1, 2, 3, 4, 5, 6, 2. There's A. M is 4, 7. Looks like we're going to be somewhere off the page here. Up here somewhere. Sorry. B is going to be somewhere up here, right? So how do we find it? Okay. Well, I know that the M is average of A and B. And that works for the x coordinate and the y coordinates. So let's try it. Let's do the x coordinates. 4 is going to be the average of 6, and I don't know, something else. We have to solve this equation. Multiply by 2, and I get 8 equals 6 plus x equals 2. That looks about right. The x coordinate of B is about 2. Let's do the y coordinate now. Y equals the y coordinate of A plus, I don't know, for B over 2. Multiply by 2 on both sides, and you get 14 equals Z plus, 2 plus Y. Subtract 2, and you get 12. That looks about right also. B is way up there, like 12. My coordinates for B are 2, 12. I'm sure you've done those before, but maybe you don't remember them. Can I remove this page? Let's go with 10 more seconds. Jot down the little bits you want. It'll be on the video if you need to go back and fill in your notes. Because I want to show you my shortcut for doing this problem. Okay. So we went from A, which was 6, 2, to the midpoint, 4, 7. And I want to go to B. If that's the midpoint, however much I traveled from A to M, I have to also travel to B. Watch how easy it is. If I went from 6 to 4, I went down 2. So I have to go down 2 again to get over here. Subtract 2 more and you get 2. If I went from 2 to 7, I went up 5. Go up 5 more, and you're done. No graphing, no algebra. Very simple, very logical. Okay? That's just a shortcut for how you do these problems where they give you the midpoint and an endpoint. Ivan?
How did you shortcut to get 12?
Okay, so look at the y coordinate change. I went from 2 to 7. That's adding 5, right? We have to add 5 again. For the x coordinates, I subtracted 2. So I have to subtract 2 again.
Okay.
Whatever you did to get to the midpoint, you have to do it again to get to the endpoint. It's kind of cool. And it does make sense. I mean, you can see it on a, if you're going from your house to your friend's house and 7-Eleven is halfway, the distance you travel to 7-Eleven is the distance you're going to travel again to get to your friend's house. Okay. And that, folks, is the lecture for today. Your homework is on Google Classroom, or it will be. And I will post this video there. Be sure you don't take the day off. And time to start doing your homework.